This is why I'm convinced that having data centers filled with GPUs is just a bad idea for most of the work that people are actually wanting to do with AI today. And this is what brings me to the interesting bit about Apple's neural engine. When the first M-series chip was released, the CPU, GPU, and NPU were all separate. But with the M5, Apple put a neural accelerator into every single GPU core. That gave it advanced multiplication capability inside the GPU, and reports suggest that this change can make the GPU run 4 times faster than the M4. We've been developing the Kira engine over the full range of Apple chips, and I can show you a performance uplift with every generation of chips. Now, of course, there will be some point when the performance curve starts to flatten, when the laws of physics and thermodynamics come into play. But right now, it's truly remarkable watching how engineers can squeeze more and more performance out of this architecture. This is why I'm convinced that having data centers filled with GPUs is just a bad idea for most of the work that people are actually wanting to do with AI today. But the entire industry, it seems, operates on a simplistic idea that bigger is better. But it doesn't work that way, and sometimes smaller and more specialized is way more efficient than simply throwing more resources at something. People need to be thinking about what is our cost per query, because the GPUs are not always the right solution for every problem. Look at the output, not the input. Look at what proportion of your workload actually needs a data center, and the real answer is probably not very much, maybe only a few curly questions here and there. But for most of the time, the advanced chip sitting on your laptop is more than good enough. That's because the Apple chip in the machine on your desk already has a matrix multiplication engine. You don't need to be renting a stretch limousine to get to the shops when your bike will get you there for the fraction of the cost.